We can see your screen if you want to make that full screen.
All right. Thank you, everyone.
Perfect.
Well, first, thanks to Stacy and Megan and Jeannie on our team for organizing this webinar. It's a real privilege for Corey and I to be here speaking to you today, and we do appreciate your time. We're going to be going through a lot of information pretty quickly today, but we hope that this basically initiates a conversation, not only today, but over the next few months for any of those who consider using these products. We are here to try to help you, so our contact information is available at the end of the webinar. Stacy has it. We'll be glad to try to help you if we haven't covered what you need today or if you have follow-up questions. So thanks again, and we'll get right into it. The agenda today is to talk just a minute about the past. I think it's important to see where we've come, then what's happening now, and then also talk about the future, the next stage for Landfire after this current phase is over. Then I'm going to turn it over to Corey, who will introduce herself later, to talk about some of the impacts and changes that you'll be able to see in some of the examples she has, BPS review, and then some support and resources. So again, we're going over a lot. It'll be pretty fast. Please hold your questions to the end, and we will try to answer them as best we can today, as well as in the future. So Landfire is a partnership between U.S. Department of the Interior, U.S. Forest Service, and the Nature Conservancy. It's a program that's designed to provide basically a tapestry of data across the entire U.S., Alaska, Hawaii, as well as some insular island territories. See two basic teams here. One of them is a small Nature Conservancy team you see on the right. On the left, much of the production is handled through the Aros Data Center in Sioux Falls, South Dakota, as well as a few people working out of Missoula, Montana. So let's talk a little bit about the past. I think it's important. And I usually boil this down to four pretty simple C's, and it's a little bit of an oversimplification, but it does help provide sort of a context for the program. It was established by a charter in 2004, so we're basically finishing our 15th year of work on the Landfire program. That charter established the constraints, the design criteria that we use, and I think of it as comprehensive, compatible, concurrent, and consistent. Now, comprehensive means that we cover every acre in the U.S. and its island territories. Compatible means the products should work together as delivered out of the box. You should not have to do any geometric transformations. The thematic layers have codes that help them match from one to the other, so they should be usable with each other as delivered out of the box. They are as current as possible. Because we're doing such a large land area, it's not possible to be immediate, shall we say, but we are working on methods to keep the products more current, and I will talk about that later. But we have made a lot of effort to try to keep the products, say, 2 to 3 years behind in most cases. And finally, we focused on trying to be consistent, and that's consistent in two ways. That is consistent geographically. So we would use the same basic data sets and processes in Florida, where I live, as well as in Alaska or Samoa or Puerto Rico or wherever it is that we're working. So try to use consistent processes, definitions, etc., so data could be compared. We also attempted to be consistent through time, but what we've learned is that it's not quite as consistent as we would like it to be. In fact, some things have been pointed out to us by some of your colleagues at the California Air Resources Board, Klaus Scott and Adam Marino. Some things we're working on, some recommendations now of trying to understand some of the changes in processes so that you could compare across versions as well. In the spirit of improving the product, it's hard to be completely consistent through time, but we did try, and we're trying to come up with some recommendations on how you can compare versions. These are our design criteria. They're the box that we operate in. And within that box, we create 20-something current and historic vegetation-related layers, fuels, condition class at 30-meter spatial resolution. And we've also created a number of quantitative state and transition models and descriptions, which Corey will talk about when she gets to her part of the webinar. So That's the basic product suite, and I'll show you a table here in a minute. We've delivered versions. The original version is circa 2000, 2001. Sometimes we call that Landfire National or Landfire Improved. Then that product was updated, not recreated, but updated in 2008, 10, 12, and 14. And we're engaged now in the Landfire Remap, which is a recreation of the majority of the spatial data layers and models. Not an update, but a recreation. That is what we're engaged in at the moment. So just to be clear, sort of get this concept and scope of the program, don't really envision that you can read this. It wasn't the intent, but just to see the products are the rows, the versions are the columns. And then there are blue geographies. There's the US, Alaska, Hawaii, and the insular territories. So you can see it's been a lot of production work, a lot of different products across many different time periods. I am seeing Megan's video now, Stacy, not my screen.
We can still see your screen just fine.
Okay,
You're
well,
good.
okay, well, okay, now it's back. Okay, thank you. All right, so moving on. This is almost the status of where we are now. This shows the current vegetation product as delivered thus far in Remap. And as of Friday, we actually have also delivered the part in the upper right that you see here, what we call the North Central GeoArea. We divide the country up into the continental US up into 6 GeoAreas, and we've now delivered 4 of the 6 GeoAreas, and that is current vegetation cover and height, as well as the fuels products, surface fuels and canopy fuels, have been delivered for about 2/3 of the continental US. So what remains the same in Landfire Remap? Well, we still have the same design criteria. We still have the same constraints. We still try to be comprehensive, compatible, consistent, and current. The basic product suite is the same, but there are changes to mapping processes and also the thematic content and resolution that were intended to improve the usability of the product. So there are some changes, and it is important to understand those changes, and we'll be talking about some of them here in a minute or two. And what also has not changed is this is still a large landscape, regional, national data set as delivered out of the box. It is not intended to replace local data where you have it. We expect local data to be of higher fidelity than Landfire data if it's available to you. So if you're looking for small geographies, then you should expect to need to do a bit, or at least some places very little, some places more, some adjustment to the products to make them reflect local conditions. It is a large landscape, regional, national data set as delivered out of the box. So what's new in Landfire? Well, we've developed a new way of sort of subdividing the country. Instead of using national land cover database map zones, we use Omernic level 3 ecoregions, which are better defined for the kind of mapping that we're doing. NLCD map zones sometimes were not defined in an ecological way, so it created some seams and things that we couldn't quite remedy. So we think going to Omernic instead of NLCD map zones has helped improve the usability of the product. We have new remote sensing methods, that is compositing, tiling, and masking methods for the satellite imagery that we use to create the product. So we think it's a more consistent and improved image base. Landfire also has used plots as the way to train all the remotely sensed processes that they've been using. And we actually have more than 1 million plots in our georeference plot database. To establish the vegetation type on those plots, we use a dichotomous key program called an auto key that we use to actually assign a vegetation type to each plot. We had some issues with those auto keys in the first version of Landfire, but in between the original version of Landfire and now, we actually spent a lot of effort analyzing and improving and revising those auto keys. So we think we have a better base data set on which to base all the mapping. We also now have Landsat 8 imagery available, which wasn't available previously before this version, as well as something called Landsat Analysis Ready data sets that we can just pull off of the shelf basically from the Department of the Interior and use those. So we have more extensive data as well as improved quality of data. One of the things we were able to do this time as well was actually conduct external reviews of the vegetation type legend, what should be mapped in an area, as well as the draft products, the final products in their draft form. We were able to actually have those reviewed, and then we were able to react to those reviews and make changes before the products were ever delivered, which is a new thing which I think really helped the quality of the products. We also now independently map National Vegetation Classification Group, a mid-scale classification like ecological systems. And before we had to crosswalk that, but now we actually have an independent map based on imagery and plots of NVC group, which is deliverable, which is delivered along with all the vegetation products. What else is new? Well, we have many more field plots. It's been 15 years. We've been collecting these plots. Some of them become too old. Some of them get have some sort of disturbance or whatever. So we do have to cull and investigate those plots for QA/QC. But we now have many, many thousands, hundreds of thousands of plots that we can use, and many hundreds of thousands more than we had originally. And something I forgot to mention is it's also important to note that we, through agreements with the NRCS, as well as with the BLM, we were able to obtain some of their internal plots, assessment, inventory, and monitoring in the case of BLM, and the natural resource inventory plots in the case of NRCS, to add those to help us have more non-forested plots in our database to help improve the shrub and the herbaceous mapping. We've also been able to incorporate LiDAR data sets and develop a method to use that LiDAR data to improve the thematic resolution of our structure product. Our height product is now quite different than it was in the past due to the ability to incorporate LiDAR data. We've also been able to incorporate National Land Cover Database continuous shrub cover data into our product, which should help us in the areas that are primarily shrub do a better job of mapping shrub cover. During the intervening period, we've also conducted a review of the biophysical settings, models, and descriptions, and Corey will be talking about that in more detail later. But we use that time to update and clean up and revise that set of models for the user base. We've added some new products. We have a historic disturbance. Instead, we can actually capture 10 years worth of disturbance now in a product so that you know the 10-year historical disturbance history of every pixel in the data set. An important change now, we also have what we call year-capable fuels products. And for those of you that actually use surface fuel models, fire behavior fuel models, either the 40 or the 13, or canopy fuels, in disturbed areas, we now transition those products. So even though this is called Landfire 2016, in those disturbed areas, the fuels products are actually representative of 2019 instead of 2016, but only in disturbed areas. The undisturbed areas are still representing 2016 in terms of the fuels products, the surface fuels as well as the canopy fuels. So that's something that's important for those who use the fuels. They're now more current than they have been in the past. And finally, we have a new backwardly compatible fire regime group schema. This has been an important variable for planning and assessment for fire programs, what's called fire regime group, which is a combination of the historical severity of fires as well as the fire return interval. The original group schema only had 5 categories, Roman numeral 1 through 5. And our users, we didn't develop that, by the way, that was in the literature, so we just implemented it. But the users indicated it didn't have enough resolution to really be useful to them on the ground. So we developed a new fire regime group schema, which is backwardly compatible. The original 5 categories are on the left. We've subdivided them by frequency so that you now, instead of fire regime group 1 being 0 to 35 years, we've now divided it up into 3 groups, 0 to 5, 6 to 15, and 16 to 35. So that should be a little bit more useful for planning to use this new fire regime group schema. These fire frequency categories were based on an analysis that was done by an independent contractor that sort of gave us an idea of where these original groups should be broken into more detailed frequency groups. So we have not delivered fire regime group yet. Fire regime group will be delivered for all of CONUS when vegetation and fuels products have been delivered for all of CONUS. So we will take that up as a product once all the other products for CONUS have been done. So let's talk just briefly about quality. There have been questions about the quality in the past, and remember, it's a large landscape database, so it's a little bit hard sometimes to define what quality means. But we've done our best to provide all the information we can to help users determine if it's usable for their application or not, or what kind of changes they might need to make it useful. So we've provided assessments of existing vegetation type for ecological systems, our native classification, NVC group, our new independent map of NVC group, as well as crosswalk, or let's just say collapsed NVC group into NVC macro group, because that's a hierarchical classification, NVC. But we crosswalked ecological systems to SAF SRM for those folks who are still using that cover type classification. So you'll see four assessments of quality are delivered at the same time as the data. We have thousands and thousands of independent plots, and by that I mean these plots that we use to assess the data, the final products, are not used to actually create the products, so they are independent. Thousands and thousands of plots sounds like a lot, but it's still not enough to do an adequate job for all categories. They were not evenly distributed geographically or thematically, so we still have some gaps in the assessment, which you will see if you download and actually look at the products. You'll see some of the issues that we had. But I believe we had 8 or 9 or 10,000 plots in the Southwest. I can't remember the exact number. So we deliver a traditional contingency table, which I'll show you in a moment. We also deliver an example of how you can collapse this contingency table into a category system that's more useful to you, because we found that many people don't use raw ecological systems or raw NVC group or raw SAF SRM. They collapse various categories, leave others the same, and we didn't provide any information on how to do that. Now we do, and I'll show you an example in just a moment. So a contingency table is basically a tally, a cross tabulation between what we called it on the map, those are the rows, versus what the plot actually was assigned to that was an independent plot in the assessment. The major diagonal indicates those things that matched. So 186 pixel plot combinations matched that were Rocky Mountain, aspen forest, and woodland. Okay, off diagonals indicate some sort of mismatch between the map product and the plot database, the independent plots. So this is the raw way to actually present the data. It's a little bit difficult because this is what the contingency table actually looks like. It's actually 202 rows by 202 columns in the Southwest, because we mapped 202 different ecological systems and 173 different NVC groups. So this is a little hard to interpret, so I'm going to show another example before. And this is another reason why we provided a way to, let's call it an example, to show you how to collapse this huge 202 by 202 into something that's a little more useful to you. So you'll find this in the assessment results. You'll find this example that shows you how to add the rows and columns so that you can put this information in a more useful format for your work. We also created something called a category agreement table. So I just pulled a piece out of what we delivered, and each row is in this case, is an ecological system that we mapped. The code for it's on the left. How many actual pixels that we mapped as, say, Southern California dry mesic chaparral, 260 pixels we mapped as that type also had plots in them that were independent that we used in the assessment. And in the other column, you'll see that 58.46, I should have rounded that off to 58%, actually of those pixels matched. So you can see for the categories that had a sufficient sample, you can see about how well we mapped that specific category instead of looking for it in a 202 by 202 matrix, okay? We also included in here in the next three columns, the three most prevalent errors that we found in the map. So in 41 pixels, we called Southern California dry mesic chaparral California mesic chaparral. So there are 41 of those of that 260 were called that particular type. And we put that in there so that people could determine for themselves whether or not that category was mapped sufficiently well for you to use as is, or do you collapse all the chaparrals into one type or another? We can't decide that for you. So hopefully this table will help you investigate specific important categories for you to see how well we feel like we map them. We're also currently working on an assessment of existing vegetation cover and height, and we're trying to develop a method for evaluating the fire behavior fuel models. Those are the surface fuel models. So far, we haven't really been able to come up with a good method for doing that, but we hope we keep trying so that we can give people more information about the quality of those products. So the future of Landfire, this remap process that we're in now will wrap up for CONUS in about the next 7 or 8 months or so. And then we'll be starting on the fire regime group products, which are fire regime group, the vegetation condition, what's called vegetation departure, and vegetation condition class, and succession class for CONUS. That will be next. And then we'll work on all the products for Alaska, Hawaii, and the island territories over the next 8 months to a year. Because remapping is more time consuming and thus more expensive than updating, we're not really sure whether we'll ever be able to do another remap. We hope we will. It'd be good to do, but we certainly cannot guarantee it. So we're actually working on a way to provide more frequent updates, say annually, delivered within a few months. Might be a rough update if you need really quick information on an annual basis, and then every 2 years develop a more complete update, perhaps every 2 years, and that would be a full update that included everything. This is still in development. We're not sure exactly what that's going to look like, but the idea of all these is to provide more timely data that's of improved quality. So now I'm going to turn it over to Corey, who's going to talk about remap improvements.
All right, thanks so much, Jim. Give us a quick second here. Perfect. Thanks, Corey.
Excellent. Okay, I was having a little trouble unmuting myself. How's my volume?
Sounds great, thanks.
Great. Okay, this is Corey Blankenship, and I am a fire ecologist with the Nature Conservancy's Landfire team based in Bend, Oregon. I'm going to pick up where Jim left off here. Jim talked about some broad stroke improvements that you're going to see in the remap data, and I'm going to drill down to specific spots on the ground to provide some more detailed examples. In the next few slides, I'm going to highlight improvements to existing vegetation products. So that's existing vegetation type, cover, and height. The reason I'm focusing on these products is because they're important inputs to other products. So they're foundational in and of themselves, but they also have a big impact on the quality of the fuels data, the succession class data, and other downstream landfire products. The first example I'm going to show here is showing an improvement in seam lines. So as Jim mentioned, the way we process imagery now using tiling and larger processing units is going to lead to fewer seam lines in the remap products. Here you see on the top image, existing vegetation cover for 2014, or in our 2014 product. And you can see the shrub cover has a kind of a stark boundary right at the map zone line. And then in the lower image, the remap product does not show that sharp distinction. So again, fewer seam lines in the remap data. Another improvement that I think users are going to find beneficial is that there's going to be finer level distinctions in existing vegetation types that we previously aggregated. So this includes types like barren, riparian, and wetland types. The example I'm showing here has 2014 existing vegetation type on the right, and you can see all the gray areas are just labeled as barren. But on the left in the remap product, you can see that now you can tell areas where there's playa, kind of shown in this to the south, versus the bedrock and scree type. So a lot more information in the legend here. We've also changed the way we've mapped existing vegetation types in disturbed areas. In previous Landfire versions, natural existing vegetation types were mapped regardless of disturbance history. What you're going to see now is shown in this example here. Starting on the right, there's the National Land Cover Data Set, and you can see in the middle this area identified as shrub, that light tan color. Sorry, that's if I said the middle, I meant the right. So on the right, the NLCD product. In the middle is our 2014 product, and you can see we mapped it as an existing vegetation type of California montane, woodland, and chaparral. Now on the left side, you see how we've mapped it in our remap product. And here we've used disturbance data, so we know this area was recently burned, and we've identified it as an existing vegetation type as recently burned shrub cover, which we believe more accurately reflects the vegetation that's on the ground today post-disturbance. We've also worked during the remap to improve the way specific, oh, sorry, I missed this. Did I miss? There we go. Okay. So we've worked on improvements to mapping invasive cover. So here, you can see a comparison of the remap data shown on the left and the 2014 product in the middle. Both of those are showing existing vegetation type with invasive annual grassland in kind of that bright blue color. And I'm comparing that here to the image on the right, which is a near real-time annual herbaceous cover product. And I'm using that as kind of the standard. We believe that that's a high quality product, and I'm comparing how well our Landfire data match that near real-time product. And you can see that the remap probably has better alignment with that annual herbaceous product. So we think we've made some improvements to mapping invasive annual grasslands. We also tried to improve the mapping of specific existing vegetation types. In this example, we're looking at how the Intermountain Basin Greasewood Flats type was mapped. In the middle graphic for the 2014 product in bright blue, you can see that Intermountain Basin Greasewood Flat is mapped across most of this area. And it's probably mapped into higher slope positions where other shrub types would be more appropriate. In remap, shown on the left, you can see that its distribution has been restricted to lower slope locations. Another area where we have tried to make improvements in remap is in the mapping of shrub cover. We've incorporated a product from the National Land Cover Dataset. It's called their Fractional Shrub Cover Dataset. And from that dataset, we've sampled additional shrub cover training data, or training plots, if you will. Here on the right, you see an area mapped in the Mojave Desert that still has some vegetation, or has some sparse vegetation on it, according to the aerial imagery on the right. And then in 2014, in the center, you can see that we identified it as sparse, less than 10% veg cover. But in remap, we've mapped it with greater than 10% cover. So the additional non-forest plots and sampling techniques we're using in Remap have increased the training data we have for these shrub and grassland systems, and we believe have improved our ability to accurately capture their cover. Another improvement to cover as well as height that you're going to see in the Remap data is that cover and height will be delivered in continuous classes. So here on the left is the height legend and on the right is cover, and you're actually only seeing part of each of the legends because I couldn't capture the entire thing and still have it be legible on the screen. Previously, these data were binned into broader classes. Cover was binned into 10% classes. For height, forest was identified by 5 different height classes, shrubs, 4 classes, and herbs in 3 different classes. So you're going to see a lot more information here in these legends, and you'll have the ability to define different classes the way you would like them. You won't have to use Landfire's preset classes. This is just a little zoom in to show you what this continuous legend is going to look like. The 2014 data on the left for existing vegetation height is dominated by 2 shades of green, so that's 2 different height classes. Then on the right, you can see the same area with a lot of different shades of green representing more fine scale variation in height across this landscape. Okay, shifting gears here a little bit. As part of the remap, we've worked not just on the spatial data, which Jim and I have been focusing on up to this point in the presentation, but also we've worked on improving the biophysical settings, models, and description data. In 2015, we initiated a review of these products. The BPS models include a description and a quantitative state and transition model that describes pre-Euro-American settlement vegetation structure, composition, and disturbance dynamics. Now, these models are an important product in and of themselves, but they also feed into other Landfire spatial products, such as the vegetation departure data and the historical fire regime products. The goals of the review were to update the biophysical settings models and descriptions with new science. We also tried to, or we did, complete succession mapping rules for every biophysical setting, and this will have an important impact on the quality of the vegetation departure products, which depend on succession class. And we developed a new model description document that includes complete S-class mapping rules, as well as the complete state and transition simulation modeling parameters. So if you don't want to open a new modeling software tool, you can get all that information in the description document itself. So we think this will be a user-friendly improvement. We made a lot of improvements to the various biophysical settings models that we have, and I'm just going to illustrate one type of change that users are going to see when we deliver these data. The example here is for the mixed evergreen forest, a major forest type in Southwest Oregon and Northwest California. This type spans a really wide gradient in precipitation, temperature, as well as topography. Now, prior to the BPS review, we had just one model to represent this forest type across its entire range, and that's shown in the column on the left. But during the review, we had reviewers indicate that this type really should be split into a couple of different models. They suggested that we define a coastal type for areas with a more maritime influence, and an interior type that would generally be found east of the crest range and at higher elevations and relatively drier sites. So what you see on those right 2 columns are the new fire regimes associated with these types. So we defined mixed evergreen coastal, which is really defined by a mixed severity fire regime, and then the mixed evergreen interior biophysical setting, which is dominated by a surface fire regime and more frequent fires. When the models, biophysical settings models and descriptions are released, you will be able to access them in a new searchable, more user-friendly interface. We think that the models for the conterminous US and Hawaii will probably be publicly released in the next year. And we're still working on the Alaska models. There have been some changes to the legend there that impact the models. And when those changes are complete, we'll be able to update the model set accordingly. Okay, this is my last major section to cover before we wrap it up and take questions. I'd like to cover just a brief application to show how landfire data are used. This example comes from some work by Gonzalez and others. They published a 2015 study where they used landfire data as the primary spatial data source for estimating above ground live carbon stocks for the whole state of California. When they did this study, they wanted a repeatable method, and they had very specific criteria for the data set that they used to do it. They wanted data that had complete coverage for the state. They wanted a data set with repeat observations. They wanted data that were publicly available. They wanted continuity of data into the future. They wanted moderate to fine spatial resolution, and they also didn't want to do a lot of pre-processing. So they wanted a data set that would be pretty ready to go out of the box, that wouldn't require a lot of upfront work. Based on these criteria, they decided that landfire data were going to be the best data set for their particular application. They chose to use the landfire existing vegetation type, cover, and height data sets, and they used two different time periods. They used the 2001 version and the 2010 version, and for each they assigned an above ground bioestimate to all unique combinations of those variables that I mentioned, the type, the cover, and the height. The biomass estimates came from different places, but for shrubs, they relied heavily on the Landfire Reference Database to get their biomass estimates. For forest and grass, the estimates were based on other non-landfire data sources. So what you're seeing here on the screen is their study area on the left, and then on the right, they've reclassified the existing vegetation type into these broad classes for their study area. The results of the study estimate the 2010 above ground biomass, and that's shown on the left. They've excluded urban and agriculture areas. And then on the right, you can see their estimate of carbon loss between 2001 and 2010. Now, I'm not a carbon expert, so I'm not going to really focus so much on the results, but I do want to highlight several of the recommendations because I found these really interesting from a data perspective. So they made a couple of recommendations for improving their estimates. One was they suggested the use of continuous height and cover products in the future. Since they used pre-remap data, they were using height and cover that were binned into classes. What they noted is that if you had small changes in the height or the cover, a change that did not necessarily cause a class change, that couldn't be detected using the landfire data. So I thought it was kind of interesting that now if they repeated this with the remap data, they would have that continuous height and cover data that they thought would improve their estimates. They also suggested that improving the existing vegetation type map accuracy would really help their analysis. And this is something we certainly aim to do in the Remap product, and hopefully you've seen quite a few examples of that today. And we do see that with the accuracy assessment for this broad area, that some improvements have been made. Okay, wrapping it up here today, I want to just go back to where Jim started, which is that we are aiming to create these comprehensive, compatible, consistent, and current data sets. And those characteristics are part of what make landfire data so useful. But it's important to remember that they're really designed for use at regional and national level scales. We encourage people to review and modify the data as needed for local use, and we have a number of resources to support that at our websites, which I'll show at the end here. With the remap data in particular, hopefully you've learned here today that we've incorporated a lot of new processes and data sets to improve these products, and they're going to come out and represent a 2016 condition on the landscape. Users can help improve Landfire products by providing plots and data, as well as feedback. So if you use the products and you have feedback for us on how we can improve them, or areas where we might be falling short, or even areas where we're doing great, you can provide that either to our help desk or through a contact us link on the website. Feel free to reach out directly to Jim or I. You can see our contact information here. And you can reach Landfire in a number of different ways. The landfire.gov website has access and information about all the individual data products. At the Nature Conservancy's Landfire Conservation Gateway website, you can get information on reviewing and editing the products, as well as a lot of information about how users have applied the data. We're on Twitter. You can find how-to videos and other information on our YouTube site. If you're interested, you could opt into our postcard to get updates from the Landfire program. And a final email address where you can reach us directly is landfire@tnc.org. So thank you everyone for your time and attention today. We really appreciate you being here. And Jim and I would be happy to take any questions you have.
Wonderful. Thanks so much to you both. So first of all, I did not unmute myself for intro. So the voice you're hearing right now is Stacey Frederick. I'm the coordinator at the California Fire Science Consortium. I put a few things in the chat box, but let me just reiterate some logistics. So first of all, we have plenty of time for questions and answers. So if you go to that questions box, you can send it to us and we'll go through them in the order that we got them. I know we have a few queued up already. While we're doing that too, I also will mention that this is going to be recorded and sent to everybody who registered, so everyone's on this list, and that will have all these links that'll be easy to access and all the contact information so you can touch in with our great presenters directly. So I'm going to go ahead and go to our first question, which is, would it be incorrect to directly compare models based on the pre-remap data from 2014 to models based on the remap data 2016?
Well, I'll answer that question as best I can. It's good, and it's going to be one of those sort of wiggly answers, as it depends on what it is. But it is true that there were some differences between remap and previous versions that could confound those comparisons. And we're working on some description of what you might be looking for. So it's not incorrect. You just have to be careful when you look at the changes and try to identify whether those changes are due to a change in process or whether they're due to a real change on the landscape themselves. And as I said, we're working on some specific recommendations to give people so that they'll kind of know what to look for when they compare the vegetation products from one version to another. So it's not wrong, you just have to be careful.
And you said you're working on some of the guidelines for that. How would be the best way to get that information? Is it going to be on your website or in your postcard, or?
We will put it in the postcard when it's available. We will post it on landfire.gov, and we'll do our best to get the word out. And we'll send it to individuals that we've been working with on these particular issues. Corey and I and the rest of the TNC team, we spend a lot of time supporting users, and we have been working with some specific groups in California on some recommendations. So perhaps they'll help us get the word out to this audience as well once we're able to provide them.
Absolutely. If the person who asked that question has a follow-up, feel free to type it. We'll come back to it. But for now, we'll move on to our next one. Oh, Corey, anything to add? Or?
No, go ahead.
Okay. So the next question is that I've heard two messages that remap represents 2016 conditions and 2019 conditions. Does it depend on the type of data, meaning the fuel model and fuel canopy characteristics that are 2019, or the others that are 2016?
Yes, it's the 2019 is strictly in the fire behavior fuel model spatial layers, Scottenberg 40 and then the 13, as well as the canopy layers, only in disturbed areas that have been disturbed in the last 10 years. So that's something you have to discern by looking at the product themselves. So it's 2019 in disturbed areas for the fuels products only. The vegetation products, existing vegetation type, cover, and height, they are strictly 2016.
This is a good segue for that same question. So when you were talking about the recently reburned, what does the recent mean?
Yes, and that would be defined by our transition rules. So I think we usually have, I'm guessing at this because I don't do this on a daily basis, but we have burned in the last year, and then we would have, I believe, there's a second category, 2 to 5, and then there's a 5 to 10 years. So I believe the recently burned is either the 1 year time since disturbance or the 2 to 5 year time since disturbance, I think, depending on where it is. But that's a specific rule that's built into the databases that would transition it depending on when the disturbance occurred. But I believe it's annual, it's 1 year or 2 to 5 years.
Perfect, thank you. The next question is, are UAS-derived imagery too fine a scale for landfire control point or calibration use?
No, in fact, we'll take any plots that we can get. It has to be a geo-referenced plot that has specific vegetation information on it. By the way, it could even be a vegetation call. If you just said it was X type, we can still use that at times for things like assessment or training or things like that, but we can't use it fully. So if it's geo-referenced, if it's in UAS or if it's on the ground or whatever, we can use it. But if it's fully geo-referenced and a full vegetation list, we can use it more fully through the program. So that would be how we would distinguish different plot types, not how it was collected, but what kind of data it has and what's the quality of the geo-referencing.
I would just add to that that we have a great team that we call the Landfire Reference Database Team, and their job is to collect the plot data and organize it in a way that it can be ingested into our process. And if you have any questions, if you have data that you think might be useful, just contact them and they'll let you know whether we can use it or not.
And so this might be a contact people directly question, but could you provide some direct resources for editing Landfire products for local applications? It sounds like those might exist online.
Yeah, so we have a couple of guidebooks that help people do that. So I would direct people to the Conservation Gateway link shown here. That's the second link on your screen now. And we have a whole section on using the products, including a couple of guidebooks on review and modification. And you'll also find resources on our YouTube site, the Landfire video shown here. So you just Google Landfire video and you'll come up with our site. And then if you don't find what you need there, just reach out to Jim or I. This is kind of an area of special interest for us, and we like to help users locally adjust the data to make it more useful for them.
Excellent. I'm going to take a brief pause here. Feel free to send in those questions. I'll just mention that a few people have, given kudos and thanks, saying that both this webinar for the update was great and that the Landfire version 2 they've been using it on the field and it's been really helpful and muchly improved. So thanks for that feedback for everybody. I also wanted to briefly say, so I just sent out a link to everybody with an evaluation survey. It is very short, less than 10 minutes, probably less than 5 minutes. It's a combination of the consortium evaluation and a few questions from Landfire directly. We do use this both kind of as feedback for our sponsors, saying this is a useful tactic still that people are really touching with webinars and that it's a good resource and information source. So if you could send that or fill those out briefly after this webinar. Also, I will put it in the follow-up email when it comes. We do have Megan, who we didn't introduce at the beginning, but she is here with the co-sponsor of today. Megan, do you want to briefly say what your program is and who you are?
Sure, thanks. My name is Megan Meyer. I'm the Forestry Extension Educator at Utah State University. And we just held Restoring the West in Logan, Utah. It's an annual conference that occurs every year in the fall, and we had many speakers reference Landfire and reference how dynamic that program is and how you guys are doing a really great job to sort of adapt to what users need. And so I think that's something that maybe needs to be highlighted. And, you know, from an outsider's perspective, that's pretty unique. In Utah, we just formed a new prescribed fire council. And while that doesn't directly relate to Landfire, some users on the webinar might be interested to learn about are doing prescribed fire in Utah, which is a great thing. And we've written, we wrote an article, or Jeannie wrote an article a couple years ago about Landfire, maybe it was last year, in our Utah Forest newsletter. So I'll put the link to that if anybody wants to read it in the chat window. And yeah, I just think you guys are doing a great job and appreciate being a partner on this and look forward to future collaborations indeed. So keep your eye out in the chat window. I'll put some information about our webinar series, which happens at least once a month, and we have an upcoming one in November. And we just had one last week that some folks might be interested in on woody vegetation removal. So we are removing a lot of pinyon juniper in Utah. And so people might want to watch that webinar when they're done with this one. So thanks for having me.
Thanks so much for joining us. It looks like we have maybe one more question. So if you have a last minute one, you might still have time to get in. But for this one, it's here in Montana. So keeping with the out-of-state theme here. Here in Montana, we're considering using Landfire version 2 to update our statewide land cover layer, which is currently based on the Northwestern REGAP. Will EVT assessments like PLOS, contingency tables, etc., be available for regions other than the one presented today?
Those products, all the assessments are available for every set of data that we have delivered. So they are certainly available for Montana. Definitely. So I would urge you to look at them and then contact me if you have any questions. But yes, they are available. And that's certainly something that should be doable using Landfire products to update a statewide assessment like that. It has been done in the past in other states. So we'd love to help you. The best part of Corey and I's job, as well as the other team members, is helping people use these products appropriately. So please definitely contact us.
So either contact you, is there what would be the best way for somebody to access that information if you wanted to walk through the steps?
All the assessment information is on the program website, which is the top link that you see it here, landfire.gov, and you'll actually see a heading that says data quality. And if you click on data quality, you'll see the remap where you click on that, and then you can go to the different parts of the country that we've delivered. To get me, just contact me directly at jim_smith@tnc.org. There's my email address. I'd be glad to help you. And I developed these products for Landfire, so I would be the right person to talk to about that. So contact me directly or go to the program website, see what you find, and then let me know.
Wonderful. Okay, well, I think that's it for questions. We are wrapping up a few minutes early here, but like I mentioned, so I'll send out an email within the next maybe week and a half that'll include the recordings and all these links, how to contact people, or you can capture them from your screen right now. I'll do one last plug and paste that link to the evaluation survey one more time. Please do take a second to take that for us. Thank you so much to all of our speakers. As I mentioned, this was kind of a joint effort from multiple groups. I think it turned out great, and I really appreciate all the work that Landfire has and continues to do for the science and management community.
Thanks to all of you for participating. We appreciate your time.